All right, welcome back to eCruz Learning because it's just that easy. With your host, Mr. Cruz, and today we're starting a completely new topic. No more graphs, no more functions, no more none of those things. Now we're starting something called multiplying polynomials. All right, multiplying polynomials. I still remember to this date when I was multiplying binomials, which is one of the examples that we're going to have today, back in high school when I was in ninth grade. Out of the entire math world, this is one of my favorite topics, so I'm going to try to be excited about it, okay, and help you understand this completely. So let's change our background to black. And here we go. The first thing that we're going to do is multiplying polynomials. But the first thing that I want you to do is understand what a polynomial is. So this is really easy. If I have one expression called 2x, okay, 2x, that is one expression. That is one expression. So therefore, this is called a monomial. Monomial, I don't know if you know mono, comes from one, okay? So monomial. And then we have, imagine that we had the expression 2x, but then I take that and let's say 2x squared, okay? But then I take that and I add 5. Because I added 5, I don't know if you recall back from pre-algebra or the beginning of algebra, that this is one term and this is another term because they have different variables, or one has a variable and the other one doesn't. Okay, or even if that's it, those are not like terms, so those are two different terms because you have two terms. This is called a binomial. Bi comes from two, so binomial. If you had three terms, and we're going to see one of those later on, it's going to be called a trinomial, and then more than three, for generalizing, we just call it a polynomial. Okay, polynomial, that's what multiplying polynomials. So here we go. Let's multiply these things. Example 1a. Okay, example 1a. Let's say that we want to multiply. Okay, let's say we want to multiply. You know what? Let's multiply these two. Why not? Example 1a is 2x times 2x squared plus 5. We want to do that. Well, you could recall back from fifth grade, the distributive property. Maybe not fifth grade, maybe eighth grade. Okay, distributive property means that whatever's outside, you have to multiply times the first term and then times the second term. So here we go. This is easy. Remember, we're multiplying. Multiply the coefficients, add the exponents. So 2 times 2 is 4. And then x times x squared, even though we don't write it, remember that there's always a 1. There's always a 1 on top of x. There's always a 1 in front of x. And there's always a 1 below of x. Right now, we only care about that one. So x times x squared is really x to the third power, because 1 plus 2 is 3. Remember, we multiply variables, we add the exponents. And then this is a plus sign. This right here is a plus sign. So I'm going to write down plus. Okay, I'm just dragging that plus sign down. And this is 2 times 5 is 10. I don't have anything to multiply the x time, so that's just x. And then that will be my answer. That's it. 4x cubed plus 10x, that is my answer. Done. All we did was distributive property. Okay, here we go. Example 1b. Let's do part B. Example 1b, even though it's going to look long, is really easy. Because remember, when you have a problem that looks long, that looks hard, if you break it down into pieces, and you go back to the basics, it's just that easy. That's why the slogan, because people say, wait a minute, math is not just that easy. Well, it's not. But if you break it down into pieces and you know the principles, the basis, then it is. That's what you want to do. You want to break down things to pieces that you know. Okay? So here's the problem. The problem reads as follows. The problem reads 3x squared, open parentheses, okay, 5x to the fifth power minus 4x cubed plus 7x squared plus 10x minus 1. Whew, we close parentheses. This is a long polynomial, okay? But if we want to simplify, this is really easy because all we have to do is use distributive property for every single term. Now, so that I don't leave any terms behind, Okay, I'm going to use the distributive property, and remember, multiply. So this is very important when you're using the distributive property. Please write this down. Please write this down. Multiply, okay, multiply coefficients, multiply coefficients, coefficients. Okay, I don't have enough space over here. Oh my goodness, this is horrible. Coefficients, okay, and and very important, add. Add the exponents. Those are the only two rules that we are using. That's all. If you know these rules, you will be able to multiply any polynomial. Here we go. Let's multiply the coefficients. 3 times 5 is 15. So I'm going to write it right below so I don't get confused. 15 x squared times x to the fifth power. We're just adding the exponents. So 2 plus 5 is 7. All right, there's a minus sign, so minus. 3 times 4 is 12, so 12. And then x, 2 plus 3 is 5, so x to the fifth power. There is a plus sign, so I rewrite a plus sign. Okay, now we go with 7. 3 times 7, 21. Okay, David, 21. And then x to the fourth power, because 2 plus 2 is 4. And there's a plus sign, so we bring down the plus sign. 3 times 10 is 30. This is getting old because even though it's a long process, now you know what to do. It's not that hard, my man. Okay, so 3x squared minus 1, that is just minus. And anything times 1 is the same thing, so it's 3x squared. Now, what you want to do is that you want to check if any of the exponents are the same. Because if any of the exponents are the same, they are like terms. But none of the exponents are the same. This is 7, this is 5, 4, 3, 2. So none of the exponents are the same. So this right here is your solution. This entire new polynomial is your solution. You just multiply a polynomial, and that's it. That's the solution. You don't have to do anything else. Remember, if you had the exponents that are the same, then you will have to combine like terms because they like each other. So they want to be together. But these are not the same. These are not equal polynomials. They don't want to be together. So that's it. Let's do example 2. Example 2. It's going to be actually, I think, easier than example 1. It's just that example 2 is here for one purpose, and it's to show you how to deal with negatives. Because you know it's hard to deal with negative people, okay? But you know that, hopefully you know the rules of negatives, okay? Hopefully you know the rules of negatives. And if you don't, I'm going to review them with you right here, right now, live. Okay, so here we go. Negative, now we're going to distribute this negative 4x to a binomial. Again, this is like example 1a. We have one monomial and one binomial, but the monomial this time is negative. So we're going to distribute negative 4x times negative 3x to the fourth power. Well, a negative times a negative, it's a positive. I'm going to do this on the side. A negative times a negative is a positive. A positive times a positive is a positive. And a positive times a negative, it's a negative. All right? Or negative times a positive is the same thing. It's the same thing. It's also a negative. All right? Remember, if good things happen to good people, that's good. So positive times a positive, that's a positive. If bad things happen to bad people, well, that's still good, all right? In math, that's still good. So it's positive because the same sign, they're positive. If the numbers are different signs, then they're negatives. So here we go. Negative 4 times negative 3 is just positive 12. Okay, so positive 12. X times x to the fourth power, that's just 1 plus 4. So that will be 5. That's 12x to the fifth power. Now you have to be careful. Before we were just bringing this positive down, but because my the number in the front it's negative, I'm gonna have to put minus because a negative times a positive is a negative. Now, if you get confused with the rules, here's what I do. When I'm doing this, I don't even care about the rules. All I do is that if the number that I'm distributing outside is negative, I need to use the opposite sign. For example, let me finish this. 4 times 2 is 8, so this will be 8. Okay, this will be 8. Let me use green for consistency. 8 and x to the fourth power. Boom, I'm done. Okay, now what I was talking about is this. Do you see how this first term was negative at the beginning? because it was negative 3x. But after I multiply, it became positive because the number outside is negative, so all I have to do is write the opposite sign. Okay, now the second term was positive, and now it became negative. So if it's negative, it will be positive. If it's positive, it will be negative. That's all I think about when I'm distributing a negative number to a polynomial. That's all you have to do, and that's it. We're done. That was example 2. Now let's do example 3. Example 3, I think it's exciting. It has a name of its own. Okay, people gave a name to this procedure. I have no idea. Well, it's just like PEMDAS, when you are simplifying. When you're simplifying uh, polynomials, so when you're simplifying an expression and you want to use order of operations, we use PEMDAS. Like, hey, if you're in trouble, llama PEMDAS. So now PEMDAS is with an M for multiplication, not for an N. But here we go. Example 3A. Okay, there's 3 different examples, 3 different types that I want to show you. The first one is this. We're going to multiply 2 binomials. The first binomial is x plus 4 times x plus 3. Okay, this is my favorite, one of my favorite things, so I hope that you enjoy them. Okay, x plus 4 times x plus 3. We're going to use a strategy called FOIL. And the first time I use it, it might take me a long time, longer than usual because I have to explain it, but then you'll see that for example B and for example Z, it'll be really easy. If you've seen this before, then let's refresh our minds because this is not that bad. FOIL stands for first. Okay, please write this down. Please write this down. First, outer. Okay, outer. The I is for inner. And the L is for last. The L is for last. So that's what FOIL stands for. First, outer, inner, last. What the heck does that mean? First, outer, inner, last. Well, this is it. Here we go. This is my first term. Okay, so and in this polynomial, and this is my first term in that polynomial. Okay, so x times x, that is x squared. Okay, that's my first. I'm done with my first. Now I'm gonna go with my outer. What are my outer terms? Well, this x is one of my outer terms. Let me use blue. This is my outer terms, and this is one of my outer terms. So you see that if you look at the first polynomial, that's the one that it's outside, and if you look at the second polynomial, that's the one that it's outside. So then I'm gonna do x times 3. That is just plus, okay, because they're both positive, 3x. That's it. If you multiply a variable times the coefficient, it's just that, 3x. We're done with outer. Let me do a blue so that you know. Now let's go with inner. Let's use some red. I have other colors here. Let's use some other random color. I don't know. Let's use this color. Let's see if not that color. It's not good looking. No, it's not very good looking. Let's use this light blue. Okay, inner are the ones that are inside. I'm guessing you got it. Those are these two right here. Those are inner. Okay, so 4 times x. 4 times x is plus 4x. Okay, plus 4x. And then the last is the last from both of them. 4 times 3. Okay, 4 times 3, which is really plus 12. But now look that this equals that, okay? But we have like terms. Check this out. We have 3x and 4x. So because we have that, we can actually set this equal to each other and say x squared, combine like terms, 3x plus 4x is 7x. So plus 7x, okay? And this is plus 12. And we are done. That's it. Now check this out. When you multiply 2 binomials, most of the time, okay, most of the time you're going to get a trinomial. The only time that you don't get a trinomial in special cases, because it's a special case, but we don't care about that right now. We care about normal cases. So when you multiply 2 binomials, you get a trinomial because it has 3 terms. It has 1, 2, and 3 terms. Remember, terms are separated by plus signs or minus signs. Okay, plus signs or minus signs. So that's it. that's called FOIL. So let's do it one more time with example B. Let's do an example B. Again, this is like a game type of thing, not that bad. Let's say you have x minus 5, okay, x minus 5 times x plus 2. So you have two binomials now that we're multiplying. The first thing that we do is first, so x times x, I mean, this equals x squared. Then we have to do outer for FOIL. So x times 2x. We're going to FOIL this. So 2 times x, that is just plus 2x. Okay. Now we're going to do inner. Now be careful. There's a minus sign. Because there's a minus sign, we have to take it in consideration when we do FOIL. So negative 5 times x is negative, okay, 5x. That's it, negative 5x. Also, the last will be negative 5 times 2, which is negative 10. All right, negative 10. Again, notice that the ones in the middle they will always combine. If they do not combine, if they're not like terms, then there was a mistake. Go back because they will always combine. So x squared 2x minus 5x, that is just negative 3x, same sign, add and keep, different sign, subtract, and then you keep the sign from the higher number, then you'll be exact, and there you go. So it will be negative 3x, and the last one, oh my goodness, just bring it down. This is negative 10, and you are done. That's it. There's nothing else to combine. You have your trinomial, x squared minus 3x minus 10. Let's do one more example. Hopefully you could get this one. Now it's your turn. So for C, this is the problem, x minus 1, x minus 3. I invite you to pause the video real quick, try to solve it, and then play it back. Okay, I'm going to give you 1 second. All right, the second pass, hopefully you paused the video to the problem. This is just FOIL. Okay, so we're going to do x times x and x times negative 3. So this is x squared minus 3x because this 3 is negative. All right, negative 3. And then you have negative 1 times x. So that will be just negative 1x. Okay, and now negative times a negative, it's a positive. So this is positive 3, and then we combine like terms because we know that the ones in the middle, they will always combine. So then that's negative 3x minus x, which is negative 4x, because same sign, add and keep, and then plus 3. Just to let you know, when I do these, I skip this step. I skip this step in my head. You don't have to skip this step, please. But just in case, just by looking at it, if you see it, if you get the same signs, you add and keep. What are you going to add? Well, the 1 and the 3. What is negative 1 minus 3 is negative 4. Here it is, negative 4x. I know that's going to be my term. My first term, if it's x and x, it will always be x squared. It will always be x squared. My last term is just multiplying the negative 1 times the negative 3, which gives me positive 3. Okay, so I skip this term, this step over here, but if you don't see it, you don't have to. All right, let's do example 4. I have two more examples and one challenge question for you. Let me change this to. All right, here we go. Example 4. Now, example 4, it's open parentheses x plus 3, okay, and then 2x squared minus 5x plus 7. So right now, what we're doing is that we're multiplying a binomial times a trinomial. If you are able to get this problem right, you will get any problem that has to deal with multiplying polynomial or two binomials correct, because this is a little bit more, it's going to be a little bit longer, but you will understand the process of it. So here we go. The first thing that we want to do is distribute that x to every single term. Now it's a trinomial, so we will have to multiply times x 3 times. So I'm going to do this in this color, okay, in orange. So this will be, please work with me, the first term will be x times 2x squared, which is really, that equals 2x cubed, because I'm adding the exponents, okay. Then x times negative 5x, that is just minus 5x. x squared, because I'm adding the exponents, and then I have x times positive 7, which is really a plus 7x. Okay, 7 doesn't have an x, so I just added 7 times x, 7x. That's it. Now let's use the light blue, okay, to do 3 times 2x squared. All right, so 3 times 2x squared, that is a positive, so that's plus 6x squared. Okay, and then we have 3 times negative 5x, so that is minus 15x. Okay, and then we have 3 times 7, which is plus 21. Notice that I used the first term of my first binomial, and I multiplied everything times x, and then I took the second term, multiplied everything times 3. Now, perfect. Now, what I can do, because this is long, what I can do is try to find some terms that I could combine. You know, you want to find that friend who likes the other friend and try to get them together for Valentine's Day. Like, would you be my Valentine? That's what we're going to do right here. We're going to look for terms that are like terms. Well, is there another 2x cubed? There's not. There's no 2x cubed, so I'm just going to write it like this. This is 2x cubed, and it stays like that. Now, negative 5x squared. Is there another squared term? Yes, there is, and it's this one right here. Plus 6x squared. Plus 6x squared. So I'm going to combine those two, and there's going to be negative 5 plus 6, different signs, subtract. So then that is going to be what? That is going to be 1x squared. Remember, when you combine like terms, you subtract the coefficients or add them, but the exponents stay the same because you're just combining like terms. Is there anything else that has an x? You have 7x, that's the next term. And yes, you do. You have negative 15x. So 7x minus 15x, okay, that will be minus 8x. And then 21 is by itself, so plus 21. That is your answer. That is your solution. That is your solution. Your solution is a polynomial. Okay, let's do one more. Let's do one more. This one is actually really good. Not that bad. This is example 5. This is example 5. I'm trying to write, and it's not working for some reason. Oh, I'm using the wrong color. That's why it's not working. Oh my goodness. All right, example 5. Example 5 says, okay, we have two binomials, 2x plus 4. Okay, but now check this out. Now we have a coefficient in the first term with the x. So what do we do if we have a coefficient with that? Well, it's easy. We just distribute, all right? Notice that 2x times 3x squared, it will be 6x cubed. Okay, also 2x times negative 1, this will be minus 2x, and that's it, minus 2x. That's it, no more. Keep it simple if it's simple. All right, and then we have the ones that they're supposed to combine. 4 times 3 is plus 12, so we have 12x squared, and then 4 times negative 1, that will be minus 4. Notice that here nothing combines. I don't know if you noticed, nothing combines, and the reason nothing combines is because this was to the first power, but then this is squared. It's not to the first power, so we didn't come with any like terms, but we need to rewrite this in standard form, which is that in descending exponents. So the 12 goes first because it has an x squared term, and then minus 2x minus 4, and that is my answer. That is my answer for that problem. And now I want to give you a challenge problem. Okay, I'm going to give you a challenge problem. I'm not going to do it. I'm just going to give you the answer. Okay, so right here, right now, live, I want you to do this. Okay, this is my challenge to you. This is my challenge to you. Try to get it right. If for some reason you cannot get it right, come back to me during class, and I will work out this problem with you. I promise. 3x squared. Okay, so we're going to multiply a binomial times a polynomial. Okay, with 4 terms. 4x squared plus 4x, okay, minus 3. I'm not going to work through it. I'm just going to give you the steps and the answer. So pause the video right now so you could try this, because in 1 second you're going to be able to see the answer, okay? So pause your video right now. All right, I hope you pause it, because here's the answer. And voila, there it is. There it is. That is the work, and that is the answer. In case that you didn't know, okay, I circled the terms that you could combine like terms with. Everything that I distributed from the negative 4x to the fourth power, I wrote it in green. Everything from 3x squared, I wrote it in blue. All the like terms that came up, I circled them in colors. They're color coded. And then in my answer, everything in green is everything that I left by itself. And then I color coded the things that combine. I hope this helped. This is how you multiply binomials. This is everything that you need to know about multiplying binomials. Remember, if you go back to the basics right here, all you have to do every single time is multiply the coefficients and add the exponents. If you do those two things, you will always get it right. And this was Mr. Cruz, because it was just that easy.